Tuesday. Sorry, Tuesday's the last time I streamed, actually, like, helping people. Wednesday was a gaming stream. I had a really fun time with you guys. We played some Roblox, and then we also played Fortnite. Lots of coffee, water, and energy drinks. Yeah, all the above. I will be, yeah, lots of stimulants. That's how I'm going to be able to teach for 24 hours. But we'll do it. All right, let's see what we got first on the queue. So again, if you ever want to figure out how to, or if you ever want to add a question to the stream here, we're just going to go to, where is it?
Hello? Yo, hello?
Yo, what's up, Shaq?
What's good, bro? How you doing, bro?
How was your Thanksgiving, dude?
It was amazing.
Hell yeah, dude. That's dope.
That's dope.
How was your Thanksgiving?
Good, dude. I ate so much food, dude. I ate
I
the
know.
world, dude.
I made this tres leches Oreo.
Ooh,
so
dude, I love
good.
tres leches. 3 milks.
Yeah.
That's what tres leches stands for, right? 3
Yeah.
milks.
Yeah.
Hell yeah,
It was
dude.
like low kind of soggy, but it's because
It was
I was
low-key kinda
rushed.
soggy?
But it was rushed. But it was still really good though.
Nice. Fire, dude.
Also, the new Fortnite season came out. Let me interrupt.
Bro,
like,
yeah, dude, you get to like surf or something, right? There's no more battle bus.
Only,
You like
only
surf.
for like a couple days. I think
And then
from
there's also a
December 4th
mobile
to something
reboot
like that.
van. Dude, there's so much new stuff on it, right?
Yeah, I just won. I dropped 24 kills. I was in the
Hell yeah, dude.
and then leave for like the next one.
We'll have to do some Fortnite this week then. I haven't played it all.
Yeah.
Well, no, I played with you guys. Well, you actually weren't there, but I did play on what was it, on Wednesday. I enjoyed it. It was fun.
Yeah. Yeah, 1 second. Okay. Cuz I got this thing, right? And I have what was it? Free nitro from something, but I used it on my other account. So I'm going to boost this server, but
Oh, hell yeah, dude.
Oh, yeah.
We love boosts. Nice.
Mhm. I'll
They
see
gave you
later,
boosts with the
bro.
free nitro. Sometimes they don't, but dope.
Yeah, they gave me two free boosts.
Fuck yeah. Let's get those boosts in.
Alright, yeah, have a good one, bro.
You too, man, dude. All right, let me make sure all my chats are working. What's up, my boy? What's up? Amir says, hey, you're back. Yeah, we're back. We're back in the saddle. What's this first question we're doing? Let's see. This is French. I think I can try to understand this. I guess these are voltages, and the elements. All of the resistors have 4 ohms of resistance. Trouver probably means find. Love you so much. Thank you, dude.
Bing, bing, bang.
I love the gifts, dude. Thank you. Okay. Find. I'm guessing the magnitude. Is that la grandeur? The magnitude and direction of I1, I2. Puissance is probably the power. Fournier means dissipated, I think. Am I learning French today? I think it's kind of cool. Yeah, all right, nice. Okay, I think we have to draw, like, we have to create loops, right? Actually, this is such a weird circuit. Let me think about how this works. Oh, actually, this isn't too bad. Right? These two are in parallel with each other, which is then in series with this. Okay. Speaking of coffee, I need coffee, yeah. I need some coffee too, honestly. You want to go get me some from Mistral? I'll take an Americano black. Okay. I'm gonna like this to me is in series with this, which is in parallel, and then this stuff is in series with this. Yes, thank you, Mistral. So let's try to draw that. So I think let me call this like just like one super resistor, because then I can figure out all the power dissipated and stuff. This is okay. But let's this is the same thing as a resistor, which is then in series with 2 resistors that are in parallel, which is and then in series with this resistor. And so if this is 4 ohms, and this is 4, and this is 4, and then this is also in 4, right? These two in parallel is 1 over 4 plus 1 over 4 to the minus 1. So that's what these are. So that's going to be 1/2, and then but flipping that becomes 2. So that's equal to 2 ohms. So then I have a 4 with a 2 with a 4. Okay, so fun. So that's equal to 8 or 10. Sorry. I can definitely do kinematics. Yeah. If you want to submit a screenshot for us to go over on the live stream here, Just go to this website, actualofficehours.com, and there you can submit something for us to go through. We already got a lot of good questions here. The real Joseph. The CEO of Chemistry Joseph? Is that the real Joseph, JC? Okay, so this is new gold stream dropped. Oh, do we have to submit through the website? Oh yeah, Evil. Yeah. Sorry. I just saw that chat from you. Yeah, the website's the best way to do it. You can still put stuff in the homework help forum for like after hours, I say, because then other people might find time to help you out on it. But the best way to get help live is to put it in the website. But I know you've been here for a bit, so I won't make you wait so long. Okay. So this is 10 ohms here, right? And actually, sorry, this is not a resistor anymore. Okay, there we go. Right? And then this like comes down. This is I1 right here. We replaced this whole thing with this. And then this comes down into another battery here. Good. And then this happens like this. Nice. Okay, I think I got this. Okay. This is a much... Good evening, coolest dude. What's up, dude? This is a much easier circuit to work with than this. This kind of sucked, honestly. This is a lot easier. And then this was E1 is 12 volts. And then this one is 4. This is actually kind of fun because they're actually all in series with each other. Okay. So let's do some loop laws. Right? So I can do a loop this way, right? And so I think what I want to do is I want to call this like I1. And then let me use different colors, sorry. Yeah. Let's say for here. You got to be careful when you have two voltages like providing current through one device. Okay. Here we go. UA minus R1, M1 minus M2. Substation electric. Dude, that's cool. Yeah, well, this is definitely some circuits. Let me see if I remember how to do this though. Sometimes I fuck this up. I think it's just 12 volts minus. I want to say minus 4I1. Do I have to include the other one though? That's the question. I forget if I have to. Well, in this case, yeah, no. It's just equal to 0. Yeah, okay. Actually, yeah. And I can already see that's what we're going to get correctly here. Because, right, straight from this, you're going to get that I1 is... Okay, so this is what I think. I think we define I1 as going in this way. Like that's like the net I1 is what it is. So I1 points in this direction. So when you're going around in this loop, it's just 12 volts minus 4I1. And that tells me right away that I1 is equal to 3 amps. Which is correct, right? This is what we have here, right? It says the magnitude and direction of I1 is 3 amps. Vers le bas. I think that means like towards the bottom, which I would agree. That does point down. It's just a whiteboard. It's called Group World. And then if we look at the other loop, which is this way, I guess, right? I want to say that one is... So this was the red loop. All right, then we can look at the gold loop. That's going to be 4 plus... Because now you're going, like, against the direction of the current. So this is plus 4I1. And then... I think we have to come up with a new current here. Right, because this all describes I1. But then this must be describing I2. Or we can call this like, yeah, I don't want to call it I2. Well, Oh, that is I2 though. Right? Because the current that goes through this thing should be the same current that goes through the whole thing here, because they're all in series with each other. Yeah. This is circuits. Yeah, this is I2. Okay. So 4 plus 4I1 and then minus 10I2. That has to all equal to 0. That might be wrong. Let's see. The correct answer is apparently 1.6. So let's see if we get that right answer. I'm curious. Because we said that I1 is equal to 3. So this is 4 plus 12 minus 10. I2 is equal to 0. I think we're okay. 16 is equal to 10 I2. So then I2 equals 1.6 amps. Which, yeah, is the correct answer. Very cool. Okay, cool. Yeah, so, and the reason for this, Moss, is this whole thing is composed of, like, this, right, which is this, these two things in parallel, which is this, and then this thing right here is technically I2. But what we know for things in series, right, is that the current, that's really, okay, cool, Jace, is that the current in all of these devices is the same. And it's also equal to what the total current of this, like, super thing is. Yeah. Group world. Group world's what I use. That's the... Everyone's asking what whiteboard I use. Okay, so then the power dissipated. Interesting. In E1. So apparently it's 55.2. I think I know where this comes from. Because there needs to be another current here. Okay. This current is not necessarily, I think, the same as this current. So this technically needs to be another current, which we can call, like, let's call it I3. Right, okay. And then if we look here, is it possible to calculate going counterclockwise? You could, but then I think the voltages would have to be backwards. Right? Because then you would be crossing the wrong direction. Usually you want batteries to go from positive to negative. But what's interesting here, okay, so at the juncture, so by juncture, or what do they call it, like Kirchhoff, KCL, current law? Is it KCL? KVL is this. These are KVL. But by KCL, current in has to equal total current out. So you have to have I3 equal to, so that's a current going into that juncture right here. That has to equal I2 plus I1. Yeah, Kirchhoff. When you take more advanced, like, electrical engineering classes, you learn there are some other really cool, like, hacks to be able to do this right. There's mesh and node analysis is another way to do this. Cool. Okay. So, this is why the current in I3, which is the current delivered by the 12 volt battery, that's equal to 3 amps plus 1.6 amps. So that's equal to 4.6 amps. Okay. So now if I want to calculate the power from battery E1, that's equal to 12 volts. It's voltage times current times 4.6. And yes, that's 48 plus 7. That's going to get me 55.6? Yeah, 55.2, 55.3.
Good job.
Nice. Why not superposition? Yeah, so, I mean, so again, this was kind of my question here, was that I could have defined... I called, like, I1, like, the total current. So this is technically the current from this minus the current from this. You're right. I kind of already embodied that superposition there. Tu parles François? Not very well. I understand it well enough to do a circuits question, at least. Okay, but this is then, yes, this is 55.2 watts. And then if you want to figure out the power in this one, okay, well, that should just be I2 times 4. Right, and that is going to be 6.4 watts, which I think is the correct answer. Yeah, 6.4. Nice. Cool, good question there. Thanks, Josh. That's a fun one.
Well done! Well done!
I like these circuits questions. Sick. You sent me a very nice diode problem. Uh-oh. Diodes are weird, right? Because there's like a voltage it has to overcome or something. And there's something, oh man, I forget. It's called like the clamping voltage. This is where we start getting into like the double E stuff that I'm just not super familiar with. Like what the hell's clamping voltage? Okay, but let me put that question in for... This is for Josh. Here we go, Josh. Nice. Threshold voltage, right? Yeah. T says, I'm studying mechanical engineering right now. Could it be possible that I'll have this subject in the future? If you, if you end up doing anything with this is useful to know just as an engineer in general. I don't have an engineering degree. I have a physics degree, but I did do a lot of circuits during my physics PhD anyways. So like knowing this is helpful. So I think even if you aren't formally tested on this, it's useful stuff to know. You typically need some circuit, right? Yeah. Yeah. All right. Next question is from Equity. Ooh, okay. Something about a plane? Oh, okay. It says the function h is defined as h of x is px plus q, where p and q are components. If the graph y equals h of x is in the xy plane, it goes through the point 0, 9. What is the function q? What is the value of q? Oh, okay. So wait, is that just, you just plug in 9 for h of x and 0 for x? I think that's what we do, right? Like, correct me if I'm wrong here, Equity, but I think this is just telling me that x equals 0, h of x is equal to 9. So, plug that in, you get 9 is equal to... P times 0 plus Q over x minus 0. Or sorry, 0 minus 3. What am I saying, dude? 0 minus 3. 0 plus 2. Yeah, you might have... Yeah. Depending on your coursework, T, it would probably be... It wouldn't be a bad idea to just do anyways, honestly. To just take it take like an EE circuits class.
What type of question is this?
This is like pretty easy. I'm confused. Like Equity usually gives me like really difficult questions because I think they were doing like a discrete math part of their chapter at some point. This is like pretty chill.
In the new Fortnite season.
I heard, dude. Jack just popped in and talked about it. Yeah, there's like mobile reboot vans and stuff.
You can revive your teammates in the back of them. You can reboot with the
there's a self reboot thing. Yeah, that one's All right, this is a pretty easy question, Equity. Equity, are you overthinking this one? But yeah. Oh, also, Justin, I played some Battlefield the other night. I need to hit you up. We should play.
I had to delete it for space. I'm not gonna lie. That's like the only other game I had. I had to delete it for space.
Oh wow.
Yeah, I didn't have space on my PlayStation to update Fortnite, so I had to delete Battlefield.
What size PS5 do you have? Do you have the 500 or what?
825 gigabyte.
Oh yeah, so you have the terabyte one. What, bro? What do you have on your PlayStation? You can't. What?
One simple game that always loves to take storage. Just guess.
COD. Get rid of COD, dude. Get rid of it, dude. No. Get rid of COD, dude. COD's trash. Wow, some people are speaking. What language is this? German. I see German in my YouTube.
Yo,
Met
what?
Naber. Is that German?
I hope you didn't just say like a racist slur or something.
Yeah.
in German.
Don't do it. Don't cancel me, please. Oh man.
Alright, I'm on.
All right. I'll see you, Justin. You're good. Don't get rid of COD. Yeah. Hi, could you explain when and what to use mesh analysis, node voltage method, or superposition method? I think I just did the superposition method. Is that kind of what I did? Again, these are all very specific electrical engineering tricks for solving circuits. Asta. I just use simple KVL, KCL, which that's what my physics education taught me to do. But I know that for complex circuits, it can be nicer to use mesh or node analysis. CAOD is overrated. Yeah. Oh, Turkish viewer. Oh, hello, Mello. Yes, if you want to submit a question, the website, actualofficehours.com. Just type your username, drag in a screenshot, I'll do it. They do. For Mistral, yeah, COD is terrible, honestly. They lost the plot, bro. For any real number, the point... Okay, this is harder. Okay. Lies in the graph. What is the value of C? Oh, okay. Okay, well, this is X. This is Y, right? So I think you just plug this in, right? So B times negative 2t plus 4 over 3 plus 3t is equal to C. Right? Oh, electronegative. Yeah, okay. Yes, and if you're a double E, you definitely have to use node mesh analysis. Yeah, Fortnite's pretty solid, honestly. Great game. What is the value of C for any real? Okay, oh, I see. So something's gonna have to cancel here. I think we're gonna have to get rid of T somehow, right? All right, let's just try to multiply this through. So what do I get? Negative 2TB over 3 plus 4/3 B plus 3T is equal to C. And it says for any real number T. Yes, I can definitely do torque T. Yeah. Yeah. I think I could just pick a value for T, no? Am I being crazy here? Yeah, right? It says for any value of T, right? So, fuck it, let's just pick something that's nice, right? Let's just say T is equal to -2. Or -1, sorry, right? So then X would be equal to 6 over 3, which would be 2. Y would be equal to -1. And then let's just plug that in. So I get 2B minus 3 is equal to C. But then wait a minute. What does B have to be equal to then? Am I going crazy here? You can't see the question? Oh, it's right here. Oh, if it's like, oh, if it's too blurry for you to watch it. Oh, so if you go to the website, actualofficehours.com, go click here on live queue, and then you can click on the username. This is Equity's question, and then the image will pop up if you want to see it. I agree. It's kind of hard to read it. Wait for any real number T. Oh, I think, okay. We need 2 equations. I need 2 different values of T. Oh, to the left it cuts off? Really? No, Equity, I see what you have to do. So you have to get 1 point. So this is like 1 equation. Then I need another value of T. Because I need to eliminate B. I see. Okay, so what if t is equal to 2. Okay. Then x would be equal to 0. And t would be 2, right? Oh, and actually that kind of solves that's our issue here. Here we go. So like, right? So b times 0 plus 6. 3 times y is equal to c. Bingo.
Bing bong.
Yeah, c is equal to 6. Got it. All right, cool. Nice. You just had to get rid of x. Is this Calc 3? No. This is like Algebra 2, I think.
Well done. Well
Not very much calculus in this. All right, nice. Another question done. Yeah, you're welcome, dude. How's so Equity just redeemed what prize did I give you? Some like master class thing in Fortnite gaming. Do you guys know about this? Destiny's Jesus or something? Here, let me give you a point for this one too, Equity. Yeah, Equity's been in our I think it was Destiny's Jesus master class. Fortnite master class. Yeah. That's it. This thing. Yeah. We give out rewards a lot for students who like ask a lot of questions, or we have a bunch of little challenges you can do in our Discord. And Equity's been in our Discord for probably like 2 or 3 years at this point. So he racked up enough rewards to get the masterclass Fortnite thing that I bought for him. So nice. I hope it's cool. I gave something similar to Cuber. I don't think it was this expensive though. I don't think I bought him like a $60 thing. I think I got him like something not as expensive. Okay. Let's see. Next question for Incerner. It's in Hungarian. I can probably chat GPT the solution. Translation. And the solution, whatever. We can, yeah. Chat's pretty good at translating. Okay, find du for f of x is equal to x squared plus xy plus y squared in the direction of that at the point 1, 1. Oh, so this is the directional derivative? Is that what this is? I think this is a directional derivative. Which I think is... I can't remember how you do directional derivatives. One second, let me figure that out. What's the directional derivative? It's grad f dotted with u over u vector. Okay, cool. Sometimes Wolfram can be helpful. A lot of times, honestly, Wolfram scares me. Like, their definitions of math stuff is kind of akin to going to WebMD to see, like, if your headache means you have cancer. They just get really serious, like, all of a sudden. Okay. Okay, so grad F is or grad big F, I guess, right? What's up, Alistair? That's the same thing as df dx, comma, then, like, df dy, right? And then now this is a vector, which means it has components. And then I think we're going to dot it with this, is what we eventually do. And then we divide by the magnitude of it, right? This might already be a unit vector, actually. I think this already is a unit vector. Yeah, oh, it says u hat, too. Oh, very cool. So I think it's just this dot u hat, right? Yeah. I think du hat is just equal to grad f dot u hat, which this is u hat, right? You can tell us because, like, the magnitude of this. So the magnitude of u hat, this would be the square root of 2 over the square root of 5 squared plus 1 over the square root of 5 squared. So this equals the square root of 4/5 plus 1/5, which is equal to square root of 5 over 5 square root of 1. So also the hat usually means it's a unit vector. Okay, so we're actually already good. du hat means like du vector. Yeah. But a hat vector means that the magnitude of the vector is 1. Okay, so df dx, partial f partial x, that's going to equal to 2x plus y, because you treat x as the only thing you're taking derivatives of, so y is 0. And then df dy, that's going to be 2y plus x. Okay, cool. So now I have 2x plus y, comma, 2y plus x, and then we're going to dot that with 2 over the square root of 5, comma, 1 over the square root of 5. Oh, and then they say at the point. So this is useful here. So, okay, cool. So at the point, 1, comma, 1. So I think I plug in 1 for x and 1 for y, right? So what is this? This is 3, comma, 3. Dot it with this. Yes, it is Jolo. Yeah. A directional derivative is just the derivative of the function, but then how much of that derivative points in the direction u. Grad has all the components at some point, yeah. Okay, cool. So this gives me, what's that? 6 over the square root of 5 plus 3 over the square root of 5. So that's equal to 9 over the square root of 5. Or 9 square root of 5 over 5. Nice. Thank you, user. I love you too. Cool. Good question. Good question, Insert here. Oh no, I'm getting flashbacks. Flashbacks to what, eh? What are you getting the flashbacks to? I thought it was pretty fun. Alright, let me mark that one as done. And then we're going to do one from the real Joseph. The real Joseph. That wasn't as bad as it looked. Yeah. It looked like it was gonna be worse for sure. It was nice that they already gave us U hat basically. They already normalized this. Otherwise, I would have had to take every component here and divided it by the magnitude of U. But yeah, I mean, this looks ugly, right? Wolfram, it's like Wikipedia. When they describe math stuff, I'm like, bro, it's not that serious, dude. Why do we have to write all this stuff? It's just the derivative of the function in vector form, dotted with u, and just make u like a unit vector. Okay, the real Joseph was doing some astrophysics. Wow. Because I'm lazy? You're not lazy, Joseph. You're the opposite of lazy. Arithmetic derivative solution. Yes. Okay. I need help not verifying this because I'm lazy. Consider a sphere illuminated from a distant light source, like the sun, like the moon illuminated with the sun. The disk that results from this has a crescent illuminated. Fractional illuminated area of the disk as views from far away is always equal to x over d. Oh, I think I see what you're saying. You're saying the ratio of this this area to this area is equal to x over d. Oh. You can't see all the screen on YouTube? We should be able to see it. Sorry, what's going on YouTube? No, YouTube should be fine. One sec, let me go figure that out. Is YouTube messing up? Let me make sure it's okay. No, it's okay. Looks all right to me. Okay, what's the equation for that crescent shape, though? Right? This is where I need Jeff to come up with like a coordinate axis, and then define like what's the equation of this. All right, let's see. Also, the reason why the moon has like a crescent shape to it, I don't think is necessarily. It's because something else is blocking it, right? So Jorgen, good. Thank you, Jorgen, for stepping up. It says from an infinitely long lens, the boundary should be half an ellipse. Is that how this works? Let me just like say, like, why is the moon a crescent? I'm just curious. Try new AI mode. Yeah, sure, whatever. Why is the moon a crescent? Yes. Right. So it has to do with like how we're viewing it, and then how the moon is getting hit by the sun. It's like a perspective thing. Yeah, an elliptic or an ecliptic. Isn't it an ecliptic equation? Right, and it's not the Earth shadow. Right. Yeah. But like, what's the equation of this ellipse, right? I'm trying to think how this works. Oh, wait. Okay, wait. I think I know this, right? Okay, let's pretend this is yeah. Let's just come up with an equation for this, right? We assume this is an ellipse. Yeah, actually, but where's it centered at though now, right? It's half the shape illuminated at an angle, so it's a projection. If I call this, for instance, right, the y-axis, and this is the x-axis, is this an ellipse that's centered here? And let's define like the center of the circle to be here, right? At like, this is 0, 0. Then well, so I could get the equation for ellipse. I think there's a formula for the area of an ellipse, right? Okay, yeah, the area of an ellipse is equal to pi AB. I didn't know that. That's actually pretty cool. Yeah, pi AB. Okay. Is it an ellipse, though? I think I'm going to assume it's an ellipse. Joseph, right? Let's assume. Let's just see if we get like similar things to what you want to say. So it has to be, right? So assuming this portion is an ellipse, then the area is equal to pi, then the semi-major axis and the semi-minor axis. But one of those is going to be d over 2, right? Because a refers to, yeah, it's like the stretchy in the x or the y. So in that case, that's d over 2. And then this amount is going to be d minus x over 2. If you turn a circle and look at it from an infinitely far away, it becomes an ellipse. Yes, because the distance, the far side versus the closer side is as it washes out. Okay. Okay, so that's the area of that portion, right? But you wanted the area of the crescent. So the crescent. This is equal to pi d over 2 squared minus this. And then sorry, is this is the whole circle, is what we're saying? Yeah. I don't know if that's gonna be exactly x over d. The crescent is half of what I have. Why is it half? So what? This is pi d squared over 4 minus, this has to like multiply through, pi d squared over 4. Yours is circle minus ellipse. Crescent is only one side of that. Oh. Oh, I see what you're saying. I felt like you're right. This is like the ellipse. Oh, okay. Right, okay. So it's half of that. Yeah. Okay. Right, alright, okay. Well, you don't divide it by a half. You multiply by a half, right? Divide it by 2. Okay, so what is that? That's pi d squared. Pi d squared over 4 minus pi d squared over 4 plus pi x over 4 all times 1/2, and then this is all divided by pi d squared over 4. So this cancels, right? Then the pi's will cancel. 4's will cancel. So I get x over 2 over d squared. You'll get a headache, yeah. So is it 1/2 x over d squared? But okay, but I'm getting x over d squared. How did we get x over d? I think it's just pi dx over 4 on top. Oh. Wait. That's not the semi-minor. D minus x over 2. Oh, it's d over 2. It's d over 2 minus x. Yes. Yeah. That's where we're making. Yep. Sorry, yeah. I was assuming I was assuming that this was now the ellipse, but then that would have a different major axis anyways. Yeah, you're right. Thank you. Good catch there. Yeah, it's just d over 2 minus x. Yes. There we go. D over 2 minus x. Okay, so now when we multiply this through, I get pi d squared over 4 minus pi d squared over 4 plus pi dx over 2. Okay, so these cancel. And then you get... Well, the pi's cancel. That cancels. Oh, very cool, actually. Yeah, watch what this comes out to be. Right, so the 1/4 and the 4th cancels. Pi cancels with pi. D cancels with one of the d's. Oh, you just get x over d. Very cool. Which is what you said. Nice. Very, very cool. That's so cool. So it's true. Love it. Thanks, Jorgen, for helping me out on that one, by the way, too. It's cool. Malik says, how are you so smart? A lot of practice. A lot of perseverance, I guess. Okay, nice. Good question. Let's mark that as done. Da-da-da-da. Lots of coffee, too. Dude, I need my coffee today. I haven't had my coffee yet today. Although I kind of don't want to do it because then I'll be up all night, and then I need to be able to wake up at 9 a.m. for the 24-hour stream on Tuesday. I need to make sure I like stock up on sleep before this. I'll do your question right now, Evoli. Which one's yours? Where'd you submit it? Oh, it's in homework help. Okay, cool. Yeah, let me get to it for you. Equity, Josh. Evoli, there we go. Got you. Yes, thank you. Here, I'll do yours. We're gonna do some statistics. A few LSDs. Yeah. I mean, acid can definitely help with certain things. I get the jug that's already prepped. You just gotta put ice in it. Oh, so you have like the cold brew? Okay, let's see. This is a stats question. Statistics. An automotive dealer wishes to try out a new customer relations sales program. The dealer randomly selects 11 salespeople and has them complete the program. The dealer then compares the number of automobiles sold before the program and after the program. At Alpha, has the program been successful? Oh, so this is like a matched pairs? It's a matched pairs t-test, I think. Right? Yeah, I think this is a matched pairs t-test. Because each salesperson is individually getting like a before and after. So, let's see, matched pairs t-test. I just gotta figure out what the equation is. Where's what? I want something that's just nice. Where's like the nice little equation? There we go. Oh, you can send the formula sheet? Yeah, you want to send the formula sheet also? So I can just like show you like where you're going to get it from your formula sheet. Right, D is the difference. D-ith is the ith. Yes, cool. Also, I'm curious. I think the TI has a matched pairs t-test thing on it. Let me see if I remember where it is. I think it's under like stats. We gotta try the calculator on. I think it's under tests here. Is it a 2 sample t-test? 2. I don't have a. Oh, there. Okay, cool. This is. Oh, there we go. Yeah, here we go. This is it. This is what I want. PDEs? I'm not the best at PDEs. Zach is pretty good at PDEs, though. He's another awesome math streamer that we collaborate with. Yes, you can also be given speaker. Come to the stage, Evoli. What's going on?
Hello.
How's your Thanksgiving weekend?
I think it went well. Just gotta do
Nice.
math homework now.
Uh-oh. Okay.
But yeah, this is like one of the one tail versus two tail tests where it has like the difference is two tails and less or greater than is one tail.
Mm-hmm. Yeah, so when they say like has the program been successful, then what you're trying to prove is specifically that that people are getting better, right? Which that to me is a one tail test. It's usually it's harder to prove that something is either getting better or worse versus is something just different. I think it's easier to prove if something's just different. But if you have to prove specifically that it's better, that I think is a one tail test. Right? Yeah, I think so.
I know that if it says like greater than or less than, it's a one tail, and if it says difference, then it's
Yes.
so that's a
Yeah, but then I think it matters on like what. So let's think about this in terms of like null hypothesis, for instance. Okay. So the null hypothesis here is that the difference between before and after is equal to 0. But then the alternative. Sorry.
To write it, he wants us to write it in a specific way.
Okay.
That's like the mean of one or mean one equals mean two, and then h1, or that's h0, and then you have h1 under it, the mean one, and then you give the greater than, less than, or no difference sign equals the mean two.
So I think this is going to be so yes. This is that the means are the same, right? Which is that there's no change, right? I think because of the wording of what the problem says, it says like, has the program been successful? You specifically want the number of cars they're selling afterwards to be greater than the number of cars they sold before. I think. Yeah?
Yeah, that makes sense to me.
Okay. So then, in order to do this, t is equal to this minus mu d over sd. Let me think how this works again. Mu d, I think, is like the average difference. But then wait, what's d bar?
Do you know like the x thing where it's like you have like the x's?
Yes.
That's
like,
d
X1.
is x1 minus x2.
Got you. Okay. So this is equal to x1 minus x2. Yeah.
Yeah, in like a column.
Uh-huh. Okay. So, okay, because then this right here, this is x, well, I think we want x2 minus x1, right? It's usually like after minus before, where I'm going to call this like x2.
He has it written as x1 minus x2, but
okay,
he also
sure.
has it written on HA It's
Yeah.
usually you put the U1, the mean one first before the mean
Got
two.
you. Okay.
I think
And
you
then-
can flip them. It
You
just gets
can.
confusing.
Yeah, it's just how you define
Yeah.
it. Pegasus, yeah, D bar is sample mean, yeah. So this is X1, and we're gonna call this X2, I guess, right?
Yeah. At least that's how
Yeah.
he has it written.
That's okay.
He's
So
very
then-
particular in how he likes things.
Statistics is all about just being particular. It's actually quite annoying,
You're
honestly.
not that guy, pal. Trust me. You're not that guy.
It's so annoying. And every teacher that does it has like kind of like their own little specific way of doing things. Yeah.
Yeah.
Okay, so if it's X1 minus X2, then I want to show that X1 is less than mu2. If it's better, right? Yeah. Okay. You call X bar? Yeah, no. It is Pegasus. It is called X bar if it's a single sample. So all right, let me think. This is a paired t-test. It is a paired t-test, yeah. Let me see their equation sheet, what do they have, though. And then D bar is the sample mean. Oh, and then the test statistics is minus U. Oh, I got you. So in this case, we're comparing that mu D is equal to 0. That's what we're getting the t value for. I want to see if the difference is away from. Okay, gotcha. Okay, so
This is hypothesis testing.
pardon?
This is hypothesis testing.
Correct. So we're gonna look at this thing right here, this t value, right? We're saying that the difference between x1 and x2, how different is that from there being 0 difference? So mu d is equal to 0.
Yeah.
Gotcha. Okay, cool. So then d bar means I have to average all. So what's that? That's like 18. Or sorry, it's x1 minus x2. So that's -2 plus 2 minus 7. So I'm just doing this one minus this one. What was that? Minus 5. I swear, I just want to calculate for this. I don't want to do all this in my head. Or here, where is no? Yeah, there we go. List, edit. Here, let me just put all these in here. So this is 16, 22, 14. The reason being is because like then calculating the standard deviation. Wait, do you have to do all this by hand?
No.
Yeah.
Well,
I remember.
we don't get a fancy calculator if we get like a standard calculator.
Okay. 20.
I mean, if we had a fancy calculator, I don't think he'd be against it, but I do not have a
You don't have the TI. gotta get you
calculator
the
on me.
The TI-84 is great. It's so nice.
Funnily
See.
enough, my grandpa has one, but he lives like an hour from here, so.
Oh no. Tell Grandpa he's gotta come over for Thanksgiving again to get leftovers or something, and he has to bring the TI-84. 20.
He didn't come over for Thanksgiving.
Oh, okay. 20, 25, 27. There we go. Okay. So that's all the data points. And then I'm gonna, this is kind of the cool thing. You can do, where's my list? I can just do list 1 minus list 2. So that's automatically gonna do that minus that. It's gonna do x1 minus x2 for us already. Maybe you can mail it to you. Yeah, Jorgen says maybe you can mail it to you. Mail is not that bad. Okay. So, and then here, I'm going to store that into a new list. I call it list 3. Okay. So now if we go to edit and we look at our lists, this is all the differences. -2, 2, -7, -5, -8, 2. And so what I can do then, I can find the average of that. So you can go to stat. Where's like average? Calc. One sec. Quit. Not abs. Min, max. Do they not have an average here? Probability. Oh, it's dumb. I know how to do this on Excel. Fine. Okay. There you go. All right, we'll just add all these. So -2 plus 2 is 0. -7, -7, -5, -12. Then -8 is -20. -2 is -22. Plus 2 is -20. -22 again. Okay. And then plus 3 is -19. -6, -25. Okay, cool. So that's equal to -25 divided by, and then how many data points do we have? We have 11. Right, 11 data points. Okay, so this is your D bar. So D bar is equal to -25 over 11. And then SD, oh wow, okay. So that's equal to S over the square root of N. So S is going to be equal to what like this individual difference is minus this squared. So for the first pair, that difference was -2, so you do -2 minus, so minus is plus 25 over 11 squared. And then you do 2 minus, so plus 25 over 11 squared. Actually, you must 12 minus 11. What's... Yeah, when we get to here. Wait, 12 minus 11? Where's 12? What are you saying 12 minus 11? Murdy.
For the S thing, I think that it's like the standard deviation, but you just replace the X's with the D's. For the sample? Standard deviation, is that weird? Yeah.
Yeah. Oh, I see what he's saying. He's saying that, so the absolute difference here is 2, and then the absolute difference here is 25 over 11. So it's 2 minus... I think that's I feel like that's the same thing, though. Yeah. Yeah, standard deviation is... Yeah. I see what you're doing. I see what you guys are doing. One sec, I gotta... TikTok is mad at me. Okay, there you go. Okay. Yes, I see. And I see why that plus there would then make things weird. But wait a minute. Yeah, okay. So it's the absolute value of the difference minus the absolute value of the average difference.
Do you see where on the chart thingy I sent where it says standard deviation?
Yes.
Not that one.
Oh, not that one. Oh, sick. Okay, yeah, got you. Yeah, here you go.
Where it says sample standard deviation?
Yes. Right here? This one right here?
Yeah. So it's just that, but you put D's where the X's are.
Oh. Oh, interesting. I'm trying to think why this is. Because usually standard deviation is like X minus X bar and then squared, and then you divide by N. But this is... Oh, wow, okay. Does that come out to be the same thing, basically? That's actually... I don't know if I've seen this equation. Sum of X bars minus sum of X... Okay. And then N in this case is equal to 11, right? Okay.
D.
Got you. Okay. So some of the squares of the differences. So that's going to be like 2 squared plus 2 squared. So here, I'll just write it out. So N equals 11, sorry. So sum of X squared, that's equal to like 2 squared plus 2 squared. Plus all these other ones. So plus 7 squared. plus 5 squared plus 8 squared plus 2 squared plus 2 squared plus 2 squared plus 0 squared. And then plus 3 squared plus 6 squared. Okay. Do chem. More chem. If you keep saying chem, this will be shown to chem people. All right, let me make sure I have enough data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, great. Okay, I'm not gonna do that. I'm gonna do this with my hand calculator because typing things just takes forever on the screen. Okay, so that's 4 plus 4 plus 49 plus 25 plus 64 plus 4 plus 4 plus 4 plus 9 plus 6 plus 36. Make sure it's right? 4, 4, 49, 25, 64, 4, 4, 4, 9, 36. Okay, so that's 203. Okay, and then sum of x squared. That's equal to, you're adding all the d's and then you square the whole total. So 2 plus 2 plus 7 plus 5 plus 8 plus 2. 2 plus 2 plus 3 plus 6. Oh, actually, no, but we have to keep the negatives. I agree, do chem. If you guys say more chem will show up. Oh, no, I need the negatives as well, though. Fuck. Oh, 1 sec. I do need to see this. Oh, but that should just be negative 25. Right? That's what we already got. Negative 2 plus 2 minus 7.
Are the summations, are those not, I mean, do you not divide those by, is it not like a mean? Like you don't divide them by 11?
We will eventually. So watch, plus 3 and then minus 6. Let me just make sure I got that right. Okay, cool. So, sum of x, that's adding up all the x values. That we got was negative 25. And that makes sense because that's what the average difference was. This d average, that was equal to sum of x, or sum of, in this case, sum of d over 11. We are mathing, James.
Oh. Okay, I did that wrong on a different one then.
Okay. Right, that's what d bar is. Because this is adding up all the differences, and then you're dividing by like how many differences there are, and that's like the average difference.
Yeah.
Yeah. Okay, but then this, I think it's 625. Okay, cool. That's 625. So then let's plug stuff into our thing. So s is equal to the square root of delta x squared. So that's 203, or sigma x squared. Sorry. Minus sigma x, all of that squared. So that's minus 625 over 11. And then this is all over 11 minus 1. And then what they say, right, is that SD, we're going to divide by another square root of n. That's hilarious. Okay. So this is equal to 3.82. And then SD is equal to S over the square root of 11. Okay, so we get 1.15. I do have a degree. I don't have a degree in stats, but I have a degree in physics. Nice. Okay, that's SD. Does that make sense how we got that, Evoli?
Yeah.
Cool. Okay. So then I'm going to do negative 25 over 11. So T is equal to negative 25 over 11. 1.67? Is it 1. No, I don't think it's 1.67. You guys stop with that. Oh, are you saying for 95%? Yeah, that is true. And then that's minus 0 all over 1.15. What's wrong, Myrtle? What background music? I think this is like Suno AI is what it is. Okay, negative 25. What's up?
And then
I get negative 1.97.
what was the alpha again?
What was the alpha? Alpha is going to be probably 0.05, yeah. Standard deviation equals the square root of 14.618. Where are you getting that from, Myrtle? Murdy? One sec. I kind of like this 1.15. This looks nice to me.
So the T would be,
T critical, right? Is what you're looking at?
yeah, on the chart would be 2.228.
Mm-hmm.
I think.
So then this is not significant.
Oh wait, never mind. That I did it for one tail or two tails, so it would be 1.812
Let me look up T table.
because I did that for one tail, not two tail. I can also share my screen if you want. I have it pulled up.
I don't think it'll let you share your screen because I think only one person can share their screen on Discord in the stage.
Oh.
But is this what you have for like a T table?
Let's see if it matches. Yeah.
Okay, cool. So I think, yeah, for one tail, right? This is all I care about. And then for
1.812.
1.812, because I think it's n-1, right? Yeah.
Yeah.
And so this is significant because this is outside that, right?
Mm-hmm.
Okay, cool. So you can say that T crit.
So like reject the
null.
or
Reject null
reject
hypothesis. Yeah, T is 1.82, and then you can say that like negative 1.97 is less than negative 1.82. So reject H not. And you can state that there is significant support to suggest that that there is a difference between the two.
Yay.
Yeah. Okay. Cool. I'm actually curious if I just throw this in the chat GPT what it gets. I just want to see. I want to see like how good its statistics is. Let's just see.
Also, would you mind sending me
Yes.
a screenshot of that?
Yes, this will all go into. So here's what I do. I do this. I say Evoli, and then I'll drop this in the thread right here. You see right there?
Yeah, thank you.
Okay, nice. Okay, cool. Good question, Evoli. That was fun. I always like doing stats with you. It's a good reminder of why I need to be better at stats.
This is by far the class that I've ever done the worst on. Like, I have never done this bad in a class.
It's okay, and also like you said, it's because the teachers are very like finicky in statistics about like it's like their way of the highway, unfortunately. Yeah, so here they got the same T critical 1.82812. I think we used a slightly different. See, our mean difference is the same too, right? 25 over 11. They use a weirder equation for standard deviation. I haven't really seen like this.
What you can do for that is you can just send in the equation. You can send in the equation you want them to use and just say wait to calculate.
Yeah. So I but I'm seeing like some of the same numbers here anyways. And then our T is bigger than that. So yeah, one-tailed. Yeah, nice. Okay, cool, great. We did it. Good job, Evoli.
Yay!
That was fun. Yeah.
I survived one question, and I have to do 24 of these on a test in an hour and 30 minutes.
Oh, it's an online test you have? It's one of those. Yeah, because you're like you're. I think you're homeschooled or something, right? Or self-study or something, right?
Well, no. So what happened recently is we moved. So I went to take classes at the high school,
Okay.
But they said, because you were homeschooled, we're going to make you take all 4 years again.
What?
Yeah, because they had the ability to accept my credits, but they didn't want to because that was a lot of work. But so I was just like, okay, can I just get like concurrent enrollment and enroll in the college with you guys, and
Yeah.
and it'll be free for me. So I'm just taking college courses, even though I'm in high school, because they said I'd have to retake 4 years with them if I wanted my
Yeah,
degree.
don't, dude. What? That would be such a setback if you had to retake 4 years of high school. Like, what? You're smarter than that. I know you are.
Yeah, I literally passed the exams that you need to get into the college courses. So
Yeah. Okay. All right. Well, I always say like, not everybody's path is like straight, but as long as it goes forward, it's okay.
yeah.
Sounds like it's
But
still
I
going
like
forward for
taking-
you.
Yeah, I like taking courses at the college more than I like high school, so it works out.
Nice. Okay. Cool. Well, let me know if you have more questions about this later.
Yeah,
I can
no, I
always help
gotta go, or I got like team practice in like 30 minutes. So
Okay. Enjoy
thank
team
you
practice.
for your help.
You're very welcome, Evoli. Always good to see you.
Yes, have a nice day.
You too. Nice. All right. Let's see. What's the next question we got? Murdy. Ooh. What's up, Murdy? Oh, is this the Hungarian question? You asked me this in Hungarian? Oh, Jesus Christ. Murdy, what do you give me here, dog? Phenomenon. Good to see you, dude. I could not take 4 more years of high school. Yeah. Ew. Yeah. JC says... Get this stuff out of here, dude. Wait, what is this question, bro? These are not diodes, dude. These are transistors. Oh. Signal processing? Maybe. Man, and this is a double amplifier. You got 2 BJTs like connected to each other. This is like double fucked. If this was a single one, like if it was just this one here on the left, I'd be cool. But like you also have the one on the right as well. Diodes are kind of transistors though, if you're thinking about it. George Floyd Fitness. Yeah, that's a username for sure. Oh man. Okay, Myrtle, I don't know how to do this because this is outside my scope of like my electrical engineering knowledge. But I'll put it in our Discord anyways, because maybe someone who does know electrical engineering will be able to do it. You gotta learn to write math proofs. Yeah, math proofs are great. You gotta prove algebra. Well, speaking of... Nice. So what we got here. Don't forget the official. George Floyd Fitness official. God damn it. What's your favorite workout day? Why make it a proof? It's already proven. It's true. For fun. Yeah, sometimes we just have fun. Thanks for the follow, by the way, Sabro. Femistral does do this for fun. All right, let's try to do this for fun. Find the surface area of the portion of the sphere x squared plus y squared plus z squared equals 4 between the planes z equals -1 and z equals square root of 3. Oh, fascinating. So, I mean, this is a sphere of radius 2, right? Agree with that? I'm like trying to draw the sphere here. This is not a very nice looking sphere. Sorry, let me get a better equation of a sphere, or a better drawing of a sphere. It's my best. Okay. Fortnite, definitely not legs. I only train for appeal. My favorite is chest day. I'm gonna do chest day tomorrow. I'm trying to hit 315. I think I've hit like 285. My beard looks so cool. Thank you, dude. All right. Doing surface area. Can I just do this as like an integral? Well, let's see. Z is like R cosine phi or something, right? Dude, my sphering is not sphering today, dude. Here, let me get this thing. Sphere, coordinate, axis, 3D. Let me just get a drawing for it, please. Drawing circles is just drawing ellipses. Yeah, I guess it can be. And then here's the question: which coordinate system are we going with? Phi's on the axial, or is it theta? I think we're gonna do this one. I forget if this is the math or the physics one. Yeah, but it wants the surface area, so. So if I do this in like spherical coordinates. It's just because we're going from down here. Let me try like polar. I think I want to do it in spherical. No. Right, and the radius there should be 2. But like, we're figuring out like what this surface area is, right? Oh, wait a minute. Could I just say it's pi r squared? Or 2 pi r, right? Okay, wait. Because I'm trying to think, how do we do the surface area of a sphere regularly, right? I think what we do. Does it work in like cylindrical? I'm trying to think how this works.
Thank you, Semester. Because you could do 2 pi r from, I don't know, in this case it's like -2. Well, we're going to change from -1 to -3. I just want to see if I get the right answer. Do spherical coordinates. It is easier. I just want to see if it works for this.
So if I wanted to, for instance, do the surface area of a sphere, let's say that the surface and it has a radius of 2. Can I do this in cylindrical coordinates? The spherical zone formula. What's the spherical zone formula? A equals 2. Yeah, this is easier in spherical. Okay. Well, in spherical coordinates, z is equal to r cosine theta, right? x is equal to r cosine phi sine theta. I think z is itself. R is square root of 3 minus 1. That's the simple formula for it? No, but I don't want to do the simple formula for it. That's cheating. I think from this, right? Okay, so x squared plus y squared is equal to 4 minus z squared. So then, if I did this in like polar, sorry, if I did this in cylindrical, right? Isn't that just like r is equal to the square root of 4 minus z squared? And then we're just integrating 2 pi r dz If you do this in Cartesian, you're ice skating uphill, dude. That would be so bad. That already sounds terrible. Damn super. Neuralski disagrees. Okay, but let me see. And then I would do this from -1 to square root of 3, right? In terms of dz. And then r is now equal to this. So you have 2 pi -1 to square root of 3, and then square root of 4 minus z squared dz. Find your surface element. Yeah, the surface element is like, yeah, okay, wait, because you're saying not a volume element, right? Yeah, it's this, right? Is this what we're saying? It's r d theta d phi sine theta. Wait, where are they getting the... Yeah, okay. Yeah, that's the other way to do it. Gotcha, okay. I wanted to maybe do it in... I'll try this method later. This is doing it in cylindrical coordinates, which I think is wrong. I think there's something about the curvature of this, like this, that this doesn't account for. Okay, but in spherical, this is going to be the integral, and then we're going to go from 0 to 2 pi d phi, and then we just got to figure out what theta is, which is not too bad. If you want to use volume, use spherical chords. How long does it take? Maybe like 30-40 minutes at this point. It depends what the queue's at. The queue's at 7 questions, so sometimes it takes me like 10 minutes to do questions, sometimes it takes me 5, sometimes in this case it might take me 20. But I would say submit it anyways, because even if I don't get to it, it all gets put in our Discord, and then we have other people that go through and help out. Okay. So z is equal to r cosine theta. So that means that theta is equal to the arc cosine of z over r, right? So we're going to go from... And then theta is measured from the z-axis. So I want to go from the square root of 3 down to the one where we get it to z equals -1. So that's arc cosine of square root of 3. Square root of 3 over 2. Oh, this is actually kind of nice. Oh, wow, look at that. Okay, and then this is the arc cosine of -1/2. Very cool. Yep, which we already know this. Yeah, that's beautiful. It's actually kind of cool. Yeah, so what is that? That's 30 degrees to 120. And then this is r squared sine theta d theta. Pi over 3 and pi over 6. Yeah. Wait, but no. It's arc cosine of negative 1/2 though, no? I think it's more than pi over 6. I think it's 5 pi over 6. Right? Because we're going from z equals -1. So that's like down here. So that angle has to be greater than pi over 2. Right? So whatever. I'm going to pull out a 2 pi because I'm going to get the 2 pi from the d phi anyways. And then the r squared is going to be times 4. And so then we have the integral from pi over 3 to 5 pi over 6. Yeah, you're good, Phenomenon. No, you're good. And then this is sine theta d theta. Okay, cool. So that's 8 pi. And then, so minus, integral of sine is minus cosine. So this is cosine of 5 pi over 6. Minus cosine of pi over 3. Which is the same fucking shit. Oh, wow. That's so fun. Yeah, because wait. This is just, this is my negative 1/2, right? And then this is my square root of 3 over 2. Wait, no. Wait. Whoa. No, this is pi over 6, not pi over 3. This is pi over 6. Oh, then this is not 5 pi over 6, sorry. This is 2 pi over 3. Right? Cosine is the biggest when this is at 30 degrees. So that's why this is pi over 6. And then for it to be negative 1/2, this has to be 60 degrees, which means it's 2 pi over 3. Got you. It's just kind of silly because it comes out anyways. Right. Let's just square root of 3 over 2. Okay, so the negative make everything positive. So is that 8 pi square root of 3 over 2 plus 1/2? Yeah, it's just integrating sine. Which integrating sine is then cosine, so then you get the same things. Narosky says, yeah. Nice. Okay, so it's 4 pi 1 plus the square root of 3. I think so. Was that... You guys had like some really easy equation for it, right? Which I think you would have gotten the same thing here. Because isn't this a trig substitution with like z equals like 2 cosine theta? Alright, so then dz is equal to... I think that's how you do this. negative 2 sine theta d theta. So then you get 2 pi integral, and it's like 4 minus 4 cosine squared theta, negative 2 sine theta d theta. And then this is, you can pull out the 4, so this is 4. What's up, AFG? So that's 4 pi. Oh, and another 2. Okay. So that's negative 8 pi. And then this is 1 minus cosine squared, which is sine squared. And integral of sine squared is just sine. So you have sine theta, but then there's another sine theta, so that's sine squared theta d theta. It's close, right? But I think it's off. And then this is still from, yeah, cosine of negative 1/2. Or cosine is square root of 3 over 2. It's actually flipped. And then we got a sine squared d theta. So this overestimates it, I guess. Yeah, because I don't think it takes into account like the curvature. Yeah, that's gonna be off, right, Feminon? It's cool. It's cool how much it's off though, by right. Do you see out here we had 8 pi? This we get like negative 8 pi. And then it's integral of sine squared. Here's just integral of sine. So yeah, this way's wrong. You can't do it that way. This way's correct. Here, let me throw this in chat real quick. Just curious what comes up. Yeah, and there you go, right? Well, it's fucking up the LaTeX, but... Dude, ChatGPT sometimes, dude. But yeah, so it's 4 pi square root of 3 plus 1, which is what we got here, right? Yeah, nice.
Oh, yeah.
Okay, what was the second part of this, though? Compute the flux. Where S is the surface and the part air, dude. What? Is this like Stokes' theorem or something? Green's theorem? Narowski? So wait, this is just all part A. This is outside my realm. Yeah, it's okay. Let's look at chat for like some help. You can solve AFG? Okay, cool. I feel like this is because what's... I think I want to put this in... Because n hat is in the r hat direction, right? But then I have to write f in terms of r hat, yeah? Or this could be a Stokes theorem. Let's see. Where's the question at? Oh, if you go to there, and then just click on the live queue, and then click on the name. It's right there. Yeah, this is it, right? Well, this is f.dr. I need, is it Green's theorem? It's something with the flux. Oh, wait. I think it's a divergence theorem. Divergence is a triple integral. Yeah. You're okay. It's okay, Narowski. Yeah, I think computing so what they want f dot n hat, which, and then they want it over in the direction towards the origin. Oh, so in this case n hat is negative r hat, right? Because then this is the surface, which we found the dA. I think the issue here is that, so f is equal to like x comma y comma z. That's in Cartesian. This is Calc 3. Erwin, yeah. So, wait, I think maybe I plugged these in? You need to find f dot n hat, right? So this is f parameterized in spherical, right? And then n hat, I think, is just equal to negative r hat. But how do you describe negative r hat in Cartesian? Yes. Yep. That's correct. AFG. Yep, we found that surface area. That's the correct surface area. It's a very simple answer. Oh, people say that it's easy. What's up, Sam? You think it's just negative 8 pi? Okay, so why'd you multiply by negative 2 pi? UC apps due tomorrow. Good luck on those, dude. That's actually early, really? I thought UC wasn't due till January. Where are you guys getting negative 2 from, by the way? Sorry, where'd you get negative 2 times that? Let me write it down. Okay. Oh wait, is this R? What's my academic background? I have a PhD in plasma physics. What is n hat? Yeah. Oh, n hat's negative r hat, right? Which, oh, I guess is equal to x I hat. Oh, okay. Oh, okay. I did just give the coordinate transforms. Yeah. Wait a minute. To x, y, z. Wait. So sorry. Is r hat the same as x hat plus y? I guess it is actually. Yeah. Wow. I'm dumb. Yes, it is x hat plus y hat plus z hat. Duh. Oh, okay. So, I see. And so f dot n hat is independent of the location. Or you'll show? Okay, cool. Yeah. So like f is equal to x hat, or it was equal to like x comma y comma z, right? And then n hat is equal to negative r hat, which is equal to negative x, or it's just equal to negative. Yeah, you can come speak, FG. What's up, dude?
Well, is there a way I can like share my screen so I can like write down the solution?
You can send me a screenshot of it. Discord won't let me put 2 screen shares on a stage. It's weird.
Okay, because I have like I can just show you in like the whiteboard.
Okay, can you take a screenshot of the whiteboard and just like paste a screenshot?
Yeah.
Yeah, just do that.
Yeah.
X, Y, Z.
Wait, so to find the flux towards the origin, you can just say that the outward unit normal vector of the sphere is n hat equals r over like lowercase r over uppercase R, which is the lowercase r is just xyz, right? And then would be and the r is over 2, so it would be xyz like the vector over 2. And then and since it's directed towards the origin, so this would be negative. So
yes.
Yeah, so this whole thing would be negative. So then f times n hat would be xyz times this, but negative. Do you get what I'm saying?
Yeah.
Yeah. So xyz times negative xyz.
Yeah.
Yeah, so then when you solve that, you should get negative 2.
Okay, well, because I get, what is this? I get x squared plus y squared plus z squared all over negative 2.
Yeah.
Oh, and then this shit's just r squared.
Or you can say x squared plus y squared. Yeah, that's just 4 over negative 2.
Wow, which is 4 over negative 2, which is equal to negative 2.
Yeah, and then so the flux would be, you integrate negative 2, which is just negative 2. Wait, no, what am I saying? You double integrate.
Yeah, but we're doing the integral of d phi or d sigma, and integral of d sigma we already found out was this, right? This is integral of d sigma.
Yeah. So then it would just be. So
Yeah. So then
like
I think
this.
I think you get negative 2 times
negative 2 times 4 pi, which is just negative 8 pi.
Yeah.
Times 1 plus 3.
Yeah.
Yeah.
That's it. That sounds pretty good. Phenomenon is like negative 2. What? It just becomes 2 times the area in part A. You think it's just positive 2? I think it's negative as well, because they're saying that in the direction towards the origin, so that's the negative r hat direction. Phenomenon, right? Common Pythagoras dub. Yeah, I think what was really messing with me is that r vector is the same thing as x comma y comma z. I should have known this. Narosky's like, oh my god, I get it now. Yeah, this was like, this is the thing that was like messing with me, and I was like, oh wait a minute. Yeah. But it also said n hat. Oh, okay. But n hat is r over the magnitude of r. Okay. Oh, that's actually really clever. Oh, yes. There we go. Yes. Yes. Very cool, AFG. Thanks, dude.
Bing bong.
Okay, that makes sense. Okay. So this is part B. So this is, yeah, this is independent of XYZ. Because eventually what you show is that, oh, well, this is also just fucking R squared. Yeah. Very cool. Okay, cool. Nice. Good question there, H.
Well done. Well done.
Sometimes things are like a lot simpler than they should be. Thank you, big smiles. Thank you, FG. I appreciate you. No, I do not use my mouse, dude. That would take forever. I use a stylus. I have a stylus. Okay. Let's get rid of all this stuff we were doing. Use the mouth if you're a real champion. That would suck, dude. Oh my god. Okay. Next one's from Moss. Ooh. We got some resistor stuff here. I'm guessing this is the question. Ooh, this is the meshes and the stuff. Okay. This is the question. Yeah. We're back to double E work. Okay. What is relative node K and the currents? Ugh, electrical. Give an equation for U2 across resistor R2 using Kirchhoff's law as a function of the source voltages. Oh, these are voltages though. Okay. It's kind of weird how they write this like this. I would just say this, right? And then this is going to be also like this. I thought you were doing actuarial stuff. What are we doing with electrical circuits? Someone submitted this. Moss submitted it almost like 2 hours ago, though. So this is back when we were doing a lot of circuit stuff earlier in the stream. Yeah, this was us. And it's funny. TikTok does this thing where whenever I talk about a certain thing, it starts showing my content towards people who also are like doing that thing. So because I was talking about doing circuits, it started showing this to people who like to do circuits. I wasn't great in high school. Please explain. Okay. The tip of the arrow is a minus. Really? Oh, I think you're right, actually. Because wait, we're defining current going this way. Oh, so it's flipped. Yeah, voltage goes up. Thanks, Moss. You're right. Germans are weird about it. Yeah, like, wait, why is this going... What? Why is that minus? What? Okay. Well, I think if I do this, right? I think for the equations... So, sorry, for U2... Oh, so U is potential. Because the way I would do this with Kirchhoff is I would say UA minus R1 I1 minus R2 I2 is equal to 0. And then I would say mu B minus R3 I3. I'll be back when we're doing statistics, Pegasus. Okay. And then minus R2 I2. I do have a text bot, though. Yeah, I think we do have a text bot. R2, I2. What aspects of math? I mean, a little bit of algebra, I guess, or linear algebra, technically. So I think this is correct, right? These are my loop laws. And then for my juncture law at K, I say that I1 plus I3 is equal to I2. Right? Yeah, can you link the answers, Moss? Yeah, can you just post them in the same thing? Because they call is this mesh analysis? I thought this is just regular KVL KCL. There we go. Oh, okay, this is cool, actually. Okay, I think this is what they mean by... Yeah. Sorry, I had to sneeze. Okay, Moss, and you posted something else. Sorry, let me go look at it. Right, so this is what we said about at the nodes, right? This is the sum of the currents has to be equal to 0, right? Current in has equal current out. And then this was the voltages. Okay, let me understand this part, the mesh part. I feel like it's similar, it's just like with additional style points. Oh, there's an image as well. Oh, you submitted another thing. Sorry, let me see it. Yes. I mean, this is okay. This is just like figuring stuff out, I think. Fascinating. Wait, whoa, what the hell? What the Haley? Also, wait, why did my TikTok go down? Excuse me? Green? Okay. But then where is ground? The bottom node. Oh, this is 0. Oh, okay, because this is always referenced. Okay, so this is like my ground. Oh, I see. That's cool. Okay, cool. So I think my TikTok... No, TikTok's still running. Okay. 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 Sorry, then why is it UA minus U2? No, shouldn't these be... One second. Yeah, wait. I1 plus I3 is equal to I2. Yeah, TikTok is messing up, yeah. Yeah, one second. I gotta restart it. Let me restart TikTok. Give me a second. It's been doing that a lot lately. One sec. Yeah, it is. So I wanted to try doing this. How do I get the gods roll gold? If you help out with questions in the, what is it? In the, I mean, you already help out with questions, so I honestly probably could give it to you. But in general, like people who understand and help out questions in the forums, I just give it to. Which, yeah, you're pretty knowledgeable person on stuff, so. I'll give you physics and math. How do we know that the voltages are the same? Here, continue live. Okay, there we go. All right, TikTok should be back at least. Thank you very much, yeah. How do we know the voltages are the same for the same cathode? So when we measure the potential across here, right? This is referenced to like some ground. And then since both of these things share the same ground, that's why we can, the voltage are the same. Well, UA is not equal to UB though, right? They're probably different values. Let me get this though. Sorry, I1 plus I3 is equal to I2. I agree with that. So shouldn't I1 equal UA? Where are you getting this U2 though? Thank you, Narosky. Yeah, okay, so I think this is the part I want to understand. I want to understand why is I1 UA minus U2 over R1? U2 is R2 I2. Oh, okay. I think I'm starting to understand this. Wait a minute. Where was it? There we go. The sum of the voltages across the resistors is equal to the sum of the voltage sources. U1 plus U2 minus UA equals that. Okay. I see where this comes from. Right. So this minus wait. U1 plus U2 minus UA is equal to 0. Or I would say that UA minus U1 minus U2 is equal to 0. That's how I would write this. In terms of like Kirchhoff's laws, right? This minus this is equal to 0. R1, R2, and R3 connect K to UA, ground, and UB. That's why you get the equation. R1 connects to UA. Oh, okay. Because he's going against the mesh rotation, right? Okay, so if you go this way, then yes, then it's plus R2 plus R1 minus UA. But wouldn't you want to go in the same direction as the mesh rotation? As the mesh? Yeah. Why would you want to go against it? Okay. Yeah, I don't think it matters either, yeah. Current through R1 is from node K towards UA. Okay. I see. And you're calling this U2 then, I guess? Is this U2 is the voltage, is the potential at K? Oh, that makes sense, right? Because this... Okay, I see. U2 minus UA, which would point in the opposite direction, but I need UA minus U2. Got you, okay. I think I get it now. I get it. This is the node. This is your ground. U2 measures the potential from here to here. So the current from here is this minus this over this. Okay, great. And then this is UB minus U2 over R3. Right. And then that has to equal the current I2, which is just U2 over R2. Oh, so this is just V over R equals I. Oh, okay. Or it's really it's delta V, right? Change in V over R. Voltage is a change in potential. It's relative. Okay. So then... and then... Wow. This is where this gets kind of crazy, though. The node potential. F equals MA, physics, baby! No, not because it's parallel. So here, yeah, let's look at this. So for instance, this is the potential here. This is U2. This is the potential at A, which is UA. Okay. So the current across here, right, from V equals IR, just individually, right? The potential, the change in potential across here, which is going to be UA minus U2 divided by R1. That's equal to I1. That's the current going through this one. Just from simple V equals IR. If you have a component and you have a voltage across it, the voltage divided by the resistance gives you the current across that device there. Right. So that's why it's UA minus U2 is that one. This one, right? Yeah, you got it, Moshi? Yeah, it's kind of cool, actually. This is UB. So then this minus this, so this potential drop divided by this resistance gives me the current going that way. Yeah, and I think that's what Narosky got as well. Right? When you get to here. So, because what was the question asking for? Sorry. Give an equation for U2, right? Yeah. So once you have this, solving for U2, it's kind of a mess actually. Yes, and those two added equal I2, and this is from KCL, right? So the current coming into a node has to equal the current going out. Fascinating. Okay. I guess it helps this mesh node, whatever analysis works, as long as you can identify that these voltage sources and this thing all have a common ground, such that this potential here is measured to 0, this potential is measured to 0, this potential is measured to 0, because the negative ends from all these things connect to each other. That's the only reason it really, I think, is really powerful. You could have done this, again, just doing Kirchhoff's law. I mean, this works as well. I mean, this basically is Kirchhoff. Okay, cool. And then, yeah, I mean, this is kind of a mess algebraically, but you get to this. Cool. And then once you have calculate the value for U2, given U1 and U3, and then you have all those. Yeah, okay, cool. Nice. Cool. Good question, actually. I appreciate. Yeah. Yeah, the first step is identifying the reference. Yeah, I agree. This is cool. It's a good refresher on, like, mesh and node analysis. Thanks, Moss.
Well done.
I appreciate that. It's kind of cool one. All right, let's mark that one as done, though. It's fun. Man, I'm getting such a crash course in circuits. The next thing is going to be when someone makes me do a Thevenin question. Or Thevenin? What language is that? I think it's in Hungarian. In Romania, we call meshes eyes. Oh, that's cool. They kind of do look like an eye, right? Like an evil eye or something, maybe. Kirchhoff's eyes. Okay, let's see what we got next. From T. Oh, Jesus. Dude, what the fuck is this? Alright. Yeah, you couldn't get wide divide the resistors. Totally Moshi. Yeah. I'm glad that helped you out. Let's get the collapse conjecture. Another go.
Good job.
No. Let's not, please. Someone always asks me about the collapse conjecture at least like once a week. I wish I was eating ramen again while watching a gold stream. That would have been so peak. Nice, Alistair. Yeah, I like ramen too. I've been making some bomb ass ramen lately. Actually, you guys want to see my ramen? I'll show you some ramen I've been making. This is pretty fire ramen. The trick is to mix the powder with like eggs and mayo or Q-pie or whatever you have first, and then like slowly pour in the boiling water. Super dope. It looks delicious, yeah, right? Yeah. That's dope.
That's dope.
Okay, sorry. Okay, oh, it's a truss diagram. Okay. I think this is Torx, maybe? Oh, it's a bridge. Dude gave a random sentence in Hungarian and said good luck. Okay, these are the loads. Okay. Sorry. Node 4, please confirm, is node 4 at 6.4? I think it's at 6,3. Right? I think it's at 6.3. Yeah. Math God save me, dude. I think this is a someone said I think this is a torque question. Ryan found a pattern in the class conjecture. Wait, so there's no torque in the x direction for anything. That's kind of cool. Sorry, and then what is this asking for? Narosky, what is this ass linear algebra question?
Surprise, motherfucker.
Okay. Calculate the support reaction of the planar truss shown, then determine the axial forces in the following common members using the methods of joints or method of sections. Oh, I don't know this. This is engineering land stuff. I feel like, oh man, this is super weird though. Like what? Right, this force is acting down. If this is like the rotation point, I guess there's just gonna be some like massive force here, right? Okay. Right. And then, yeah, sum of forces X, sum of forces Y. The internal bar forces. Oh, wow. Okay. I don't think I can do this in 25 minutes. I appreciate you submitted it to you though, but it's cool. Just because this is pretty involved engineering. But I like to see it. It's cool. I mean, this is how they build bridges and shit. Okay, I'll mark this one as done. I'll see if someone else wants to attempt it later. Just, it seems like it's an engineering question, and then here, I'll put what the text was for this. Imagine someone submitting the Riemann hypothesis as a homework question. They do that. They definitely do that. People have done that. People think they're funny. Let me see. Who have I... H, I did one of your questions already. Noroski, I haven't done one of yours, right? Wait, what the hell? My solution is 3 pages long.
No.
Oh my god, dude, what? I've successfully found that these points satisfy the system of equations and that they are in fact the only solutions. However, my solution is 3 pages long. I'm hoping for a more sane method to do this. Okay. Find the matrices AB such that a squared plus 2b is equal to that. AB plus BA is equal to that. Oh. Oh, and that's the pairs of AB. So A can equal that, B can equal that, A can equal that, B can equal that. Is this like doing linear out? Sorry, sorry. You're doing like a systems of equations with matrices? That's pretty cool. Wait, but how do you do this? I mean, I could assign like A has like A1, A2, A3, A4. But then like A squared? Oh man, this becomes a mess. Sorry, let me put this over here. Why this? That's the translation for that one. While Gold attempts to solve, I don't know if I can solve this. Dude, this is 3 pages? Dude, what? But AFG, yeah. If you want to write something up, that's cool. Because, I mean, I don't know. I would say that A is equal to like, what, like A1, A2, A3, A4. And then am I going to calculate what A squared is? And then see what B squared is, and then this component, right, plus this component has to equal this. This just becomes an insane amount of systems of equations to solve. Yeah, right. Yeah. That's what I would do it. System of 8 equations. Yeah, because you have to figure that's A, right? And then B is equal to B1, B2, B3, B4. and then write out what all this stuff is. I feel like there's got to be like some simpler, cute little linear algebra tricks for this though. Okay. Well, here, I'm gonna... I think AFG probably has an idea of it. I don't know. But what I'll do here, I'll post this. In the thread. So here, let me... And then I'll tag AFG in it. So, here, Naroska, your question, I'm gonna say like, AFG. If you want to post your write-up, that's cool. Yeah, and they both have to annihilate 1, 1 to 0 so that they have the same subspace. Okay, so there we go. Thanks, AFG. AFG's earning his math god role. Okay. Let me see someone else I haven't answered. Did I do highs? Ooh, okay. Ooh, I kind of like this. Rhesus factor? Oh, this is like 8. Oh, this is a little bit of stats. Someone was asking about stats. Was this you, Pegasus? Human blood can be classified. Yeah, is also characterized as plus minus of the rhesus factor. Table shows a distribution. If one of these people who is rhesus negative is chosen at random, what's the probability that the person has blood type B is okay. What is the value of X? Stats traumatize me. Oh, this is cool. So this is like the probability of B given that you're negative. This is like conditional probability, right? So this is equal to... And then we got to figure out what this is. Okay, cool. Let me get... What's it? Conditional... I forget what it is. I think it's... Yeah, this is what I want. Thank you. Or this actually works too. Oh wow, you wrote it up that quickly, AFG? What the hell? The helly? Here, I'll post a PDF in so you can see it easier. Can I just see this? Yeah, thank you. All right, let's see real quick. X equals that, Y equals that. Assume A equals to AX plus BY. B equals CX plus DY. That took 3 minutes? Dude, that's impressive, bro, dude. Since X squared equals 2X, XY equals X, YX equals X, Y squared equals Y. 2a squared plus 2abx plus b squared y. Oh, because xy equals x and yx equals x. Narowski's asking, why can we assume those are forms for a and b? Okay, one sec. Let me. Yeah, I was getting kind of. All right, let's see this real quick. Okay, probability of A given B is the probability of A and B. So this is gonna be the probability of B and negative over the probability of just being negative. And we know this is equal to 1/9, right? Because that's what we said. So the probability of being B and being negative. So being B and being negative is 2. Two over whatever this total is. Let's see. We add these all up. 33 plus 9 plus 3 plus 37 plus 7 plus 2 plus 1. 33 plus 9. 37 plus 7 plus 2 plus 1. So that's 92. It's 92 plus x. Right? The total of all these numbers is 92. Okay, and then the probability of just being negative is equal to 7 plus 2 plus 1 plus x. So that's 10 plus x all over 92 plus x. Oh, okay, cool. So then, if we do this divided by this, these will actually cancel. Love that. So you get 2 over 10 plus x is equal to 1/9. Oh, not bad. So 2 over 10 plus x is equal to the same thing as 2 over 18. So x equals 8. Nice. How's the queue? We're getting through them. I just did highest question. This was a cool one. Yeah, this is conditional probability. Nice. That was highs. Let me download this. Yeah, you can, Jay. Yeah. Yeah, just join our Discord and then throw it in the homework help and then just tag me. I'll take a look at it. Cause yeah, I got 14 minutes left on this one. Yeah, you got it. Yeah, so again, yeah, if you're just finding us today, the website that people are using to submit questions is this actualofficehours.com. Make sure you click here, join our Discord, because that's where all the cool kids are, and that's where if you have questions outside of this live stream, you can ask them there. Also, like for instance here, this is great. Narosky and AFG, like we're talking about, this was a question that came up that was kind of difficult. Narosky, AFG came and wrote a solution, and then you can like discuss about it, which is great. Love your Discord. I was the one that asked the projectile question. Oh yeah, I remember you, Jay. Yeah, I remember you for sure. Did you have a test coming up? I think you had a test with like 2D like stuff. Three minutes is very quick, Alistair. Yeah. All right, nice. Let me see. I like this one. This is from Dieps. This is a momentum question. Physics. Yeah, math comps suck, dude. AFG. That or like the JEE stuff. Okay. Well, see, this is a momentum. This is cool. Yeah, you're probably doing like dynamics then next, Jay. Thuma. Okay. Q, the macaroni penguin collides elastically. Elastically is cool. Elastic collisions means that kinetic energy is conserved. I love the names of these penguins, by the way. Zaza, the rockhopper penguin. Q, the macaroni. What's a macaroni penguin? Okay. Q speed is that initially rest. Calculate the velocities after the collision. This is cool. So, momentum before has equal momentum afterwards. There's a shortcut to this. I know it's like coefficient of restitution or something, right? So momentum before you have the 5 times the 3.2 plus 0 because this has no momentum, and then afterwards we're gonna have 5 times, let's say like v1 plus 3 times v2. Cool. So this is one equation we have. 16 is equal to 5v1 plus 3v2. Now, because kinetic energy is conserved, I also know that the kinetic energies have to be the same. So here, Ke before has to equal Ke afterwards. And if we remember kinetic energy, it's 1/2 mv squared. So this is 1/2 times 5 times 3.2 squared has to equal 1/2 times 5 times v1 squared plus 1/2 times 3 times v2 squared. You can cancel all the 1/2s. Those go away. Zaza. What is Zaza? This is an anime character or something? Oh, weed is Zaza? Oh, interesting. I haven't heard that one before. That's got to be some dialect or something. Okay, cool. So then we have two equations, right? I have this and I have this, and I got to solve for v1 and v2. Which is annoying. Because, I mean, you can write v1 in terms of v2 and then plug it in. That's a quadratic, right? Yeah. Just kind of annoying. So is that 51.2? And then you have 16 is equal to 5v1 plus 3v2. AFG is my supplier. Yeah. Thanks, AFG. 2D subalgebra. Alright, so is there an easier way to solve this? I think I square this and then maybe subtract this and then no, but then I have a v1 v2 cross term. I just really don't want to do this. $6.7. Kids. Okay. Ooh, Thuma, tell me, dude, is YouTube Shorts the new thing for, like, the next generation coming up? I've heard, like, so Vine was, like, my generation. Then it became Instagram. And then it was TikTok. And now I hear, like, YouTube Shorts is the new thing for, like, Gen Alpha. Which would explain, like, why my YouTube Shorts are blowing up. Pretty much? Okay. Well, good thing I do stuff on YouTube, then. I do a lot on YouTube. We hit 10K on YouTube.
Oh, yeah.
Bingo. All right, 51.2 is equal to 5 times, like, this mess, like, square, dude. What? This just sucks. Plus 3v2 squared. There's got to be a better way. I don't really want to solve this. I'm going to throw it in a calculator. Because I just don't want to do this. It's just messy. If your teacher's making you do this, that's not nice. So we can do 5 times 16 minus 3x We do that squared. And actually, oh, no. Wait, where'd my calculator go? Come back. That's going to get a 25 on the bottom. So actually, this is all just divided by 5. Because there's a 5 on the outside. So we just do this divided by 5. And then I say plus 3x squared. And then this all needs to equal to 51.2. Okay, so let me trace. Let me change my window. Y max needs to be like 60. Not 660. Come on. You gotta hit. It hits in 2 places, actually. Oh, but I'm pretty sure we want the positive one. We don't want Zaza to be going backwards. That would make no sense, right? You can't hit Zaza and have Zaza start moving towards you. Okay, cool. X equals 4. Ooh, it's actually kind of a nice number. Wow. Okay, cool. So you get V2 equals 4. So then if V2 equals 4, V1 equals 16 minus 12 over 5. So that's equal to 4/5. Nice, cool. Meters per second. Nice. Okay, cool. Great question there. Thanks, Dieps. This is fun physics.
Well done! Well done!
Let's see, that was 3. All right, let's see what else we can do in the next 4 minutes. What do we got? Murdy, I did one of yours earlier, did I not? Oh, is this the linear phase? Oh, man. Ooh, I don't know if I can do this in 4 minutes. A polynomial function has 4 x-intercepts. The constant q is equal to the y-coordinate, the y-intercept, and the r. I don't know if I can do that one. Well, wait, y-coordinate? Oh, I don't think actually this is too bad, actually. Wait, I think I can do this one. Right? I don't feel like this one's too bad. Yeah, so if it has those x-intercepts, right? That means you have x plus 7, x plus 4, x minus 2, x minus 3. So the y-intercept is at x equals 0. So if you just plug that in, right? So you get that f of 0 is equal to, what's that, 7 times 4 times minus 2. What's up, mathematician? Times minus 3. So that's 28, negative 56, 168. Right, 28, 56, 150, yeah. 168. And then that's Q. And R is equal to the product of the roots. Well, aren't these the roots? So I feel like R is equal to the same thing. Because that's equal to negative 7 times negative 4 times 2 times 3. Which is the same as this, right? The minus signs are just shifted around. So that's also equal to 168. So Q plus R is equal to 336. Yeah, cool. You have school tomorrow. Uh-oh. I know. A lot of people have school tomorrow. Nice. This was SD's question. Right? Yeah, that was yours, SD. Okay. That wasn't too bad. It was January. It's definitely not January. Zaza for bond coin. A good trade. The only way you can earn bond coins is for doing academic things, not connecting your dealer. All right, let's see. This looks fun. Do you have insomnia in your lifetime? I definitely have had insomnia, but I'm also really good at sleeping. Become an expert at sleeping. All right, we got 30 seconds left. I don't know why that timer is off. Okay, here we go. In the following equation, C is a positive constant. Which of the following is one of the solutions to the given equation? Actualofficehours.com, although I am ending the stream soon. But please submit anyways. I mean, any question we don't get to will get done at another time. Oh, you know what it is? It's because my clock is off. This clock is... Dude. The clock on my desktop is wrong. Dude, can we... What? Adjust the date and time. Dude, yeah, what? There you go. Fix the clock. There you go. Fixed it. Bum, 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 bum. Okay, so I think you multiply this by same denominator, right? X squared minus c squared. And then so you get that x squared is equal to c squared plus 39 square root of x squared minus c squared, right? Because now these all have the same denominator. I can just cancel the denominator out. So then, and then what are we looking for? Which of the following is a solution? Oh, I guess for x, right? Oh man, this is kind of ugly. Wait, how do you get this? Oh, wait. X squared minus c squared is equal to 39 square root of x squared minus c squared. What's up? Everyone in the Discord today.
Nice.
Fuck. Is this where you just plug it in and just see if it works? I don't think x can equal c squared, by the way. I don't think x can equal c, because then you're dividing by 0, which is bad. So I don't think this works. The other ones might. We're hitting maximum time. Dude, I struggle on problems all the time, dude. That's false. I struggle on things all the time. Life is a constant struggle. He always does. What's up, Kuda? Thank you for the server boost, by the way. What are we at? How many boosts do we have? What are we at? Wow, 15. Y'all are dope, dude. Thank you. Oh, it's you, Shaq. Why is your name Kuda now, dude? What? Oh, that's your new account. What's your best tips for studying biochem and physics for Olympiads and competitions and whatnot? Studying for competition questions is basically doing competition questions. Because I mean, I think as we saw earlier on someone submitted kind of a competition level type question earlier. You just have to know like the 100-page quick trick solution on the top of your head. So doing questions is the best way to get better at competition questions, because I know people even with like PhDs in like math and physics who like can't solve some of the competition questions because they assume so much like kind of random knowledge of different theorems and things that like you're just like, wait, what? Oh, nice. That's the free count. Wish me luck, please, bro. I gotta deal with biotech next semester with 20 pages of slides. Dude, that sucks, dude. What? You guys are off. Okay, I'm running out of time. I do have to go teach another student, so we'll get to this one. I'll put this in the Discord. All right. Let's close out the stream. There we go. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate everyone's questions and the stuff we went through. Thank you everyone. Yes, AFG, Thuma, Sexy Grandma, Kuda, all you guys are great. Appreciate you all. Yeah, thanks for being awesome. Our next stream will be tomorrow, so that's going to be at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. So if you want to figure out whenever we're streaming, go to this website, actualofficehours.com, and go to click the streaming schedule. And so this has the schedule for when we're streaming. I'm doing a 24-hour stream on Tuesday. So come by Tuesday. It's going to be a marathon. Be more enthusiastic. Wait, what are you saying, dude? Okay, but we do have office hours tomorrow. Yes. And so, yes, to anyone who submitted a question and we didn't get to it because we ran out a little bit of time. We're very close here, Thuma. I would have liked to do this one. This one's not too bad to do, but everything that we didn't get to automatically gets put in the Discord, and then there we have some awesome actual educators, my friends, and other really smart people in my Discord, and they help out and they donate their time and solve things, and I appreciate them. Okay, you're just here for the coin. Okay. All right. Okay, you guys are great. All right. We'll see you tomorrow. Thank you, Jorgen, for your help as well. Again, everyone in the chat is great. I appreciate you guys helping me out because I can't solve everything. I just provide the platform to do it. Thank you. All right, if you're watching us on Twitch, which is the supreme platform to watch us because it's nice and horizontal, we're going to go raid somebody. So let's see who we're going to go raid. Dun, 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 dun. People doing arc raiders, fork fights. Dun, dun. Oh, Science is doing some it looks like they're doing Minecraft. That's fun. I don't think I've ever seen Science game. Okay, go say hi to Science for us. All right, good to see you, Femvox. We're just ending the stream right now. Anyways, stream was great. Thank you, Fem. But yeah, okay, enjoy the rest of your weekend. Go load up on turkey. Get ready for school tomorrow. We'll see you. Peace.